Hi, this video is about the Caribou Mathematics Contest. I'm going to show the solution for the February 2015 Grade 9-10 Contest, question 19, which also came up in the Grade 11-12 contest. Now, the question is, how long would it roughly take to play all possible chess games? For simplicity, we assume that in each position there are 40 possible moves. Each game lasts 50 moves. From each game, all moves are played. Every second one move is played, and that each year has 365 days. Hint: at first determine the number of games and then the time needed to play them. Use the following approximate relations. Okay, alright. Now, from the question we know that each position there are 40 possible moves. And we also know that each game lasts 50 moves. And the hint is at first determine the number of games. Alright, now let's pretend that each game lasts only 2 moves instead of 50. Now that would mean for the first move we would have 40 different possibilities, and for each of those 40 different possibilities we would have 40 different possibilities for the second move. So that would be 40 times 40 total games being played, which is also 40 squared. And that's only if we have each game lasting 2 moves, but each game lasts 50 moves. So therefore we would have 40 times 40 times 40 times 40 and so on, 50 times, because each game lasts 50 moves. So therefore we would have 40 to the power of 50 games. Alright. Now, from the question, every second one move is played. Well, that means that we want this in terms of moves and not games. Okay. Now, from the question, we know that each game lasts 50 moves. So that means that for each of these 40 to the power of 50 games, each of those games lasts 50 moves. So to find the total number of moves, we must multiply this by 50. And that would be 50 moves per game. And now we can already cancel out the G and the G. So therefore we are left with 40 to the power of 50 times 50 moves. Alright. Now looking at the options, we can see that they're all in terms of years. And we're also given every second one move is played. So therefore we want to find the time. We don't want to find the moves. Alright. And we are given a relation, every second one move is played. So therefore we will multiply this by 1, and that will be seconds per move. And now we can already, again, cancel out the moves, and therefore we are left with 40 to the power 50 times 50 times 1 seconds. Alright. Okay. But now we want the options in years, and right now we have seconds. So let's go to the next bigger thing than seconds, which is minutes. Alright, now to get to minutes, we would have to divide this by 60 because there are 60 seconds in a minute. But we want to find hours now. So there are 60 minutes in an hour. So that means 60 times 60 is 3,600. That means that there are 3,600 seconds in an hour. So we will divide this by 3,600, which is also just multiplying it by the inverse. Okay, and this is hours per second. Hours divided by seconds. And now we can cancel out the seconds. So we are left with this, hours. Okay. And now the next biggest thing from hours is days. And we know that there are 24 hours in a day. So we will divide this by 24, which is again just multiplying by the inverse, which is just 1 over 24. And that is days divided by hours. And again, we can just quickly cancel out the hours, and we have this many days. Alright, and finally, all the options are in years, so instead of days, we want years. And there are 365 days in a year. So we must, again, divide this by 365, or just multiply by the inverse. And that is years per days, divided by days, and now again we can just quickly cancel the days. So we have this many years. Okay, now this looks very hard to calculate, so we will make it easier. Okay, now from the question, we are given relations for all the numbers we have used in terms of powers of 10. Okay, now we start with 40. And 40 from the question is 10 to the power of 1.6. And we will do that in brackets. And we know that that all is to the power of 50. So we will just leave that as 50. Okay, and now we have times 50. And 50 is 10 to the power of 1.7. Okay, and now we have times 1, and we can just leave this because it's just times 1, so it stays the same. Or, if we want to follow the same pattern, then 1 is also 10 to the power of 0, and adding 0 to this by using one of the power rules, it's just 1.7 plus 0 is 1.7. So it stays the same. Okay. Then we have, now we have 1 over 3,600. And 3,600 is 10 to the power of 3.5. Now instead of writing 1 over that, we will just write 10 to the power of negative 3.5, because that means the same thing. Alright, now we have times 1 over 24, and 24 is 10 to the power of 1.4, and we will just write times 10 to the power of negative 1.4. Okay, and now we have times 1 over 365. 365 is 10 to the power of 2.6, so we will just have times 10 to the power of negative 2.6, and then we have that in years. Okay, alright, now using one of the power rules, we will do 1.6 times 50. Now 1 times 50 is 50, 0.6 times 50 is 30, 50 plus 30 is 80, so we have 10 to the power of 80. Alright, and now we just have times 10 to the power of 1.7. And then times 10 to the power of, okay. So now, again, using another power rule, we will do negative 3.5 minus 1.4 minus 2.6. Well, minus 1.4 minus 2.6 is negative 4, negative 7.5. Alright. Now, we have, and now this is all in years. Okay. Now we have 80 minus 7.5 is 72.5. 72.5 plus 1 is 73.5. And then 73.5 plus 0.7 is 74.2. So this is 10 to the power of 74.2 years. Alright, now looking at all the options, we can see that the answer is option G, 10 to the power of 74.2 years. If you'd like to know more about this contest, please feel free to visit our website at cariboutest.com.